Now, penicillins are a group of antibiotics, and these antibiotics are used to treat bacterial infections. And penicillin is derived from the Penicillium fungi. It can be taken orally or it can be taken by injection. Now, all penicillins are characterized by the presence of a beta-lactam ring. This is the beta-lactam ring here. And you will see the beta-lactam ring in all penicillins. This is responsible for the antibacterial properties of the drug. So this is how it looks like. I've shown all the carbon in the beta-lactam ring. So this is a carbon, carbon, and carbon again. Just to make it a little bit clearer, so you can see that this carbon is forming 1, 2, 3, 4 bonds. This one, 1, 2, 3, 4 bonds. This one, 1, 2, 3, 4 bonds. Normally in such organic structures, we don't show the edge. That's why it's just left blank. But if we're drawing the full structure, we should know that there is a hydrogen here. Right? So this is the beta-lactam ring, and the two carbons here and here, they are forming, they have 4 regions of negative charge, so they're forming 4 bonds. So this is sp3 hybridized. The nitrogen, so I'll show you 1, 2, 3 regions of negative charge, and it has a lone pair. So there's 4 regions of negative charge, so this is also sp3 hybridized. This carbon here has 1, 2, 3 regions of negative charge, therefore this is sp2 hybrid. So sp3 means that bond angle is 109.5, sp2 means that bond angle is 120. As they bind together, eventually the bond angle in the ring is reduced to around 90 degrees, which means that there is a lot of strain on the bonds, which means that they can be broken very easily. Now, when the beta-lactam ring breaks open because of the strain, because of the 90 degrees angle strain over here, it binds to the enzyme responsible for creating the cross-links in the cell wall of the bacteria. So this is the structure of a bacterial cell, and you can see the cell wall over here. So the cell wall is a rigid structure, and it gives the shape to the bacterial cell, and it also protects the cell from the internal pressure due to water present here. So there's water minerals in the bacterial cell, and the cell wall will prevent the bacterial cell from bursting. But the beta-lactam rings is going to open up and bind irreversibly to the enzyme responsible to make these cell wall, which means that once the beta-lactam ring binds to that enzyme, the cell wall weakens. And when the cell wall weakens, more and more water can come into the cell. And when water gets into the cell, the pressure inside the bacterial cell is going to become high, and it's going to burst the bacterial cell. So this is how the beta-lactam antibiotics act on the cell wall. Now, there's different mode of action of antibiotics. Some of them interfere with the formation of the cell membrane. Some of them interfere with the formation of proteins inside the bacterial cell. So there's many ways that antibiotics damage bacterial cell. But in any case, penicillin is only going to affect the bacterial cell. It has no effect on the human cells or the animal cells, because the animal cells do not have a cell wall.